Binomial theorem. Okay, so expansion. We definitely don't want to do x plus 1 multiplied to itself and FOIL that 6 times, well, total of 5 times. No way. So what we need is the triangle. Okay, so let's get the triangle out here, and I'm going to do this in pencil, actually. So we got to go all the way up to the 6th one, and then for this one, we need to go up to the 3rd. So that's not too bad, but this guy, we're going to have to go to the 6th. So we're going to have to recreate our triangle here. Okay, so there's the 3rd one. I'll use it here. And I need those triangle numbers so that I can get those coefficients that need to be there. Okay, so here's where I will stop. Those are my triangle numbers. And what this means is those guys are going to multiply to all of the other terms that I'm going to get as I kind of go through the 3 strands. All right, now that's just a weird thing to say, but I hope it makes sense to you. Let's see how this rolls. Okay, I'm going to need a little room here. I'm going to have 1, 6, 15, 20, 15, 6, and 1. Now, I do believe one of these will be multiple choice and the other one will not. So you will have to do it by hand. So let's go ahead and then start with this A term. He will start at the 6th degree and then he will go down in power. Then we'll do the 1 and then he will go up in power. Okay, so this is actually going to be kind of easy here. Not too bad. X to the 6th, X to the 5th, X to the 4th, X to the 3rd, X to the 2nd, X, and then no X. And this guy's 1, so he'll be 1 to the 0, and then 1 to the 1, 1 to the 2, 1 to the 3, 1 to the 4, 1 to the 5, and then 1 to the 6th. Now what we've got here is because we have addition in both cases, so that's nice, we can just make it, all of them are going to be added to each other. If this was negative, then we would be alternating each one, starting positive, then negative, positive, then negative, positive, and then negative. But in this case, we're going to multiply going down. Okay, now I know it might look a little like synthetic division, but you're not adding these going down. You're multiplying. So this is going to be x to the 6th plus 6x to the 5th. Plus, oh, this is nice because the triangle numbers are just as they are. All right, there we go. Not too bad. We did this in probably a 20th of the time of what it would have taken to FOIL those out. X plus 1 times X plus 1 times X. To FOIL those out each individually would have taken us probably half an hour and we would have made a mistake. So this is very quick. All right, now let's go here. Now our triangle number is 1, 3, 3, and 1. But now what we've got to do is we have to raise 2x to the 3rd and 2x to the 2nd. 2x to the 1st, and then no 2x. Then there's no 3, but 3x to the 1st, 3x to the 2nd, 3x to the 3rd. So notice, again, triangle numbers form the basis at the top. Then the first term descends in degree. The second term ascends in degree. Okay? Okay, so now we've got 8, because 2 to the 3rd power is 8. 8 times 1 is just 8. And then the x to the 3rd. And we do have addition here, so we will just go plus. And now we've got 2 to the 2nd power is 4, times 3 is 12, times 3 again is actually 36, x squared. Now we've got 2 times 6, okay, 2 to the 1st power is 2, 2 times 3 is 6, 6 times 9 is 54, x to the 2nd power, oh, just x. That's why I used pencil for this one. Okay, and then this guy at the end is just, there's no x anymore. He's just going to be 3 to the 3rd, which is 27. So that is our final answer. Okay? Okay, so now, what is this polynomial divided by here? Now, we've already done a problem like that, but what we didn't do, they asked if there was a factor. Okay, and that was the factor theorem. This is just synthetic division. So what we do is we do the same thing as what we would do with the factor theorem, but we might have a different result here. Let's see if we actually get a remainder. If we don't get a remainder, it still doesn't matter. We just need to show what is left after we divide it. Okay, so they're asking a kind of a different question in a way. Okay, and then this is 4, and that's positive 36, so it looks like we get a positive 6. So we do have a remainder. So here's the thing. This is, I just showed the work, okay? And if I were to divide this guy, okay? Okay, I took this cubic divided by this polynomial, and I'm going to get a quadratic. This guy's x to the second and x. Here is just the constant term, and then he is a remainder. So what you've got to do is remember what we do with the remainder. We simply tack it on like that. Okay, this is our final answer. And you must show this work. This is that's you don't need to show that. You could go from here straight to here, but you've got to know what to do with the remainder. Okay. All right, 32. 33, evaluate this guy. Okay, now it does say use the remainder theorem. So this means I have to use synthetic division because that's what the remainder theorem requires. So let's go ahead and do that. Now I will tell you on the test, you're probably going to be missing a term here. So make sure that you put in a 0. If this guy wasn't there, if you just had that, you'd have to put it a 0 for him. Okay, so make sure that that is the case. I don't think that showed up on this practice test. I can't put everything on, or there's always something that I forget to put on. But watch out for that. You're going to drop 1, negative 5. This adds up to negative 7. That's 35. Add that together. That's 33. And then 5 times 33 is going to be 33 times 5 is 15. That's 165. Okay, it's going to be negative, so add those together, negative 166. Okay, and I'll tell you, though, that doing this by hand, this is so much faster, probably than typing that into a calculator, to be honest with you. I had to do a little multiplication by hand, but that was no big deal. It's just a 2-digit times 1 digit. So that is the final answer there. Okay, we got to sketch a possible graph here. So let's see, I do see a negative, so it is a negative, and it is a negative even. Okay, now this is just for me. A negative even just basically means that I have it like this. Both the arrows go down because we have 1, 2, 3, 4, 5, 6. We have a 6th degree function here, and we've got a negative sign in the front. This is completely factored. So somebody factored it for us. Cool, thank you. And now what we do is we know that the arrows have to be pointing down. So I'm just going to be making a little note there. So it looks like I hit the x-axis at 0. Here, I hit the x-axis also at negative 3. And then I hit it at positive 4. Okay, so it looks like these guys are going to come from the bottom. It's going to hit negative 3. And because we have a multiplicity of 2, I will actually bounce. I will bounce off of him, but then I have to come back up somewhere between here, come back up and pass through 0. Now, when I go through 0, it looks like I am just literally passing through. So this guy can come as low as he wants. He will pass through. Now, I do have to reconnect here. What happens when I go through 4? It looks like I've got a 3. That is an odd degree, so somewhere he's got to come through. And he's just got to brush right through it. And there we go. And there was our reconnection. So this is perfectly fine, although you could have just went like this. Like that. Could have went like this. Gotten a little taller. Okay, either way, these are all possibilities here. But these guys right here would have been necessary. Okay, so there's just this, and those guys right there are necessary. That is how I'm going to be grading it. Okay. All right, last one. Last one here is, this is use a graphing calculator. Now, we've already done a problem like this, but we used a quadratic. Okay. So what I don't want you to worry about this too much, because when you when you type this in, you're going to go 2x to the third, and then plus 4x squared, plus 3x, plus 27. Okay, zoom standard. Okay, where does it equal 0? Looks like it's only -3. That's the only place where it actually hits the x-axis. When you see something equaling 0, what you are essentially asking is, where does it hit the x-axis? Just like what we did here. If we were to set this equal to 0, we know where it hits the x-axis, and that's why we're able to identify those points. So all we're doing is a natural extension here, but we don't know the factored form. So we can't sketch it, but we can graph it on the graphic calculator, okay? And so our final answer here is just C, okay? Now we didn't really work with that, but you know, you can kind of, I'm hoping that a lot of you guys get this one correct, so I can actually kind of include it on the test, and it's not hard. But you know, if a lot of you get this one wrong, then it basically becomes extra credit for those of you that do get it right. So if you can remember this, that any polynomial equaling to 0, you can solve it on the graphing calculator by looking at where it hits the x-axis. That's it, okay? All right, so let's just make a note there, hits x-axis. All right, good luck, everybody. I know these videos are long, but you can, if you are still listening, that means that you're really thinking about, whoa, is this guy going to give us a hint on the final exam? And I am, because if you've stuck with me right now, and if you put a star next to the last letter of your first name, then I will give you 3 extra credit points because you're hanging around to the end of the video. And I think that's cool, and I would consider you a home. So have a good night.